All right, and we are live. So, good morning, good afternoon, and good evening to our viewers from all around the world. Thank you for joining us for yet another webinar by AppSecEngineer. I'm your host Anish Bhargav, and I'm joined by Abhishek Dharani, Senior Security Engineer at AppSecEngineer and one of our esteemed instructors. So, thanks for joining us, Abhishek.
Thank you, Anish. Good to be here.
So, I just want to give you guys a quick primer on what this webinar is about. So, this webinar will just be a small taste of what you can expect from our full 4-day bootcamp hosted live by our instructors at AppSec Engineer. So we have 6 different boot camps covering topics like threat modeling, DevSecops, AI security, secure code review, cloud native security, and of course this one, supply chain security. So I'll give you the full details on all the exciting stuff coming up in our live boot camps at the end of this webinar. So stay tuned. And I also have a little gift for all of you people who will stay to the end of the webinar. So you trust me, you don't want to miss this one. So let's get back to what we're our topic for the day, which is supply chain security. So, Abhishek, can you tell us a little bit about what you're going to be discussing today?
Hey folks, welcome to the webinar of attacking the application supply chain. So we're going to talk, this is going to be a short webinar on the landscape of supply chain and how the industry is pretty much shaped by a lot of supply chain attack vectors. So prior to starting, let me just quickly introduce myself. I'm Abhishek Dharani, and I'm a senior security engineer at P45. I do a lot of things ranging from PAPTs to security architecture reviews. I'm also a content creator at AppSecEngineer. And in my spare time, I also do a lot of bug bounty hunting. On Google, we have the HackerBug bug crowd. To end it all, I've also trained at Black Hat. So let's jump into it. Our agenda for this webinar is going to look like this. We're gonna start with what supply chain basically is. We're also going to talk about MITRE attack framework and how the supply chain framework kind of fits in within this MITRE attack framework. We'll also have a quick look at the supply chain life cycle. And we'll just zone, opposed which we'll be zoning in into infrastructure as a code, IAC, and Terraform in specific. And to end it all, we'll be looking at one of our flagship labs that we have on malicious Terraform models. So let's jump right in. So this is pretty much a straightforward definition by Dan Gear, and Dan Gear says defines supply chain as a software supply chain is composed of the components, libraries, tools, and processes used to develop, build, and publish a software artifact. I mean, to be honest, this is pretty straightforward, but to add a couple of statements on top of this, if your organization or team is to supply a software to the world, every single component that goes into that process will be part of your supply chain, will be part of your software supply chain. So moving forward, here are some statistics by Sonatype. And Sonatype is basically a software supply chain management company that provides a lot of data insights as to with regards to a lot of open source components being used in applications worldwide. And they say that 98% of software projects use open source components. These components make up over 75% of the code in the app. So, I mean, this is pretty much obvious because no one is going to reinvent the wheel anymore. We are always going to build on top of things. And Sonatype also says that 84% had at least one vulnerability. Typical application has 158 vulnerabilities, 60% of them with at least one high severity issues. And so let's get real. I mean, the numbers are pretty staggering. And though they do not reject the idea of using open source components, but they do tell us that using them blindly can cause a lot of issues down the line. So this is how the landscape looks like. And moving forward, this is how your web application supply chain would look like. So if you have to have a web application up and ready, it would depend on a lot of such components. It would depend, you pretty much have a server-side component there, running your application's database, talking to a lot of other frameworks right behind the scenes or at the server level. You also have a front-end client side, factory ready, wherein you have a lot of JavaScript libraries, you have a lot of widgets, You have SSR frameworks, all of them in there to give a good UI UX to your end user. You also have to deal with CI/CD systems, continuous integration, continuous deployments. You also have containers, Kubernetes, and place. You'll have serverless frameworks ranging from AWS Lambda, Lambda extensions, serverless deployment tools. And you might also make use of infrastructure as a code. You might make use of Terraform, Ansible to deploy your resources to the cloud. And you might also have a lot of cloud native components in the play, such as API gateways, log monitoring libraries. So all these components pretty much help your web app function. But all this come with a catch. All these components are inherently dependent on something else. They're inherently dependent on external frameworks. So these external frameworks can act as entry points, for your supply chain. In your supply chain journey, they can act as threat vectors within your supply chain framework or pipeline. So moving on, let's talk about supply chain security and the MITRE ATT&CK framework. The MITRE ATT&CK framework basically is a library of TTPs. So when I say TTPs, they mean tactics, techniques, and procedures. So TTPs are very important if you want to ever threat model a system. So again, tactics is basically, if I were to define tactics, tactics basically mean the why or basically the goal of an attacker. The techniques basically entail the sort of steps or the high level overview of sort of steps the attacker is going to take in order to achieve their goal. And procedures are detailed steps that anyone can follow or any malicious actor can follow in order to finally achieve them. So, I mean, again, this is very much useful in development of threat models based on real world scenarios. You also have these TTPs. Okay, again, the TTPs are not generic in nature. You have TTPs, for specific categories such as enterprises, such as mobiles, containers, Kubernetes. Each category has their own set of TTPs. So moving forward, where would supply chain fit in here? MITRE ATT&CK also has a lot of matrices. They have matrices such as reconnaissance, they have matrices such as initial access, privilege escalation. They have also 9 such matrices. So one of these matrices is initial access, and supply chain pretty much is all about that. So if you were to have a supply chain threat vector, it would all start from gaining access to an organization's trust boundary. That is what an adversary would look into. The first initial step would be to figuring out how would they get access within your organization's trust boundary. So supply chain attacks are pretty much based on top of this. 80% of such an attack is all about reconnaissance, to be honest, and with good reconnaissance, you would have a good foothold of the organization's landscape, and it would be easier to pinpoint initial access or initial entry points within that trust boundary. Post which, it's all about privilege escalation, elevation of the privileges, trying to achieve the next few steps of escalation, and to eventually compromise the entire system. So that would obviously and always be an end goal for an adversary. So moving on, this is how a supply chain life cycle looks like from the developer's perspective. So the day-to-day activity of a developer would be to write the source code, then build the source code, and during this process, you'll have a lot of dependencies being pulled in. So post this, when the application is functioning and is pretty much ready to be deployed, it will be deployed as a package, which an end consumer would make use of. So again, this is the basic life cycle. This is how it looks like. But if you have to look at the threat vectors, if you have to look at supply chain threat vectors, you see that these threat vectors exist at every stage of this life cycle. So right from the get-go, right from the developer who's writing the source code, you will have threat vectors such as dependency confusions. You'll have malicious git hooks. You'll have Terraform modules which are malicious in nature. So the threat starts right from inception of an application, and it also moves on to the build category, the build aspect of it. So you might also have a poison pipeline. You have build system compromise, wherein the build systems such as maybe Jenkins that your using is compromised. And once it is compromised, it leads to a lot more other things. And during the build process, you also have a lot of dependencies being put in. Again, dependencies can be external frameworks that your application relies on. Because again, no one's going to reinvent the wheel. We will always pretty much build on top of what is already there. And you might assume that you are safe when you have a package ready in your registry, but there are also various threat vectors or threat attacks that can happen there, such as package integrity attacks, malicious base images that are vulnerable right from the get-go, and registry is lacking integrity checks on the same. So you have all these sorts of things.
So what I'd imagine is that like when you have these supply chain issues at one stage of the life cycle, they would kind of lead to ripple effects across the entire SDLC, right?
Exactly, Anish. So it pretty much is similar to a domino effect. You just have the first piece in motion, and the rest pretty much follow. So it's like that. So it's like imagine a chain with a lot of components, and if one of those components get corrupted, so it's all attached. It's all connected together. So it's all about escalation from that point.
Mhm.
Yeah. Moving on, let's kind of zone in into infrastructure as a whole under the supply chain attack landscape. So IAC, and again, stands for infrastructure as a code. And as the name says, it lets one write instructions to deploy actual resources in the cloud. So again, from the traditional method where you will have to spin up resources manually. So instead of pretty much doing that, you just write a specific manifest of instructions that would talk to your cloud provider and spin up the required resources. So one of those tools that help us do this is Terraform. Then you also have Ansible. You also have CloudFormation. So, and again, it pretty much makes life easier for the developer because this manifest can be shared with the community, and anyone can pretty much pick the same thing up and use them in use it in their application workflow. So this is well and good, but again, IAC, if you do remember the web application, the supply chain overview, IAC was one of those components, and we pretty much investigate a good threat vector within this component going forward. But prior to doing so, let us understand what Terraform actually is. So Terraform pretty much deals with providers, models, and resources. But at the heart of Terraform, you have providers and resources. So again, assume that your task that spinning up a couple of EC2 instances on AWS. So you will have to talk to an AWS provider. So Terraform gives you a lot of such official providers, basically binaries. Again, providers are plugins or binaries that would help one interact with cloud environments. So you have an AWS provider. If you want to talk, if you want to spin up resources under Azure, you'll have an Azure provider. So, and again, these are all found in the Terraform registry, which is, I can just also quickly show that up. So the Terraform registry looks like this. You can browse providers here, and you have official providers, your partner providers, you also have community providers. So the AWS provider would pretty much look like this. And again, this is maintained by HashiCorp. So they will be responsible for maintaining and checking and making sure that the source code ain't tainted. So this is how it looks like. And when we talk about resources, when you talk about resources, they are basic components within this cloud provider. So EC2 instance is a resource under the AWS provider. So AWS system parameter is another example. So again, Terraform is all about manifest, writing instructions to deploy resources in the cloud. Now, modules, on the other hand, are basically manifests that you can share with the world. Because let's be real, it's not, no one would be interested in, or no one would be, it would be frustrating to write the same set of instructions again and again. So why not package it out as a module, put it up there in the registry, and anyone who's pretty much looking forward to deploying similar resources on their provider can make use of that specific module. So these are the three pillars of Terraform if you were to have a look. But moving forward, one of the interesting security considerations that Terraform providers have is that they kind of enforce GPG private key signatures on this provider. So providers basically are housed on in GitHub repositories, and post which, in order for you to push, if you were to push a provider to the Terraform registry, to the official Terraform registry, you will have to sign it with the GPG private key, and then submit GPT. I mean, you have these actions which are automated workflows or automated pipelines that they're gonna. These pipelines are pretty much responsible for taking your provider repository and signing it with the GPG key. And the GPG key is obviously also provided to the Terraform registry in order to validate whether the signature holds. So there's a good sense of integrity checks that do happen in this specific life cycle of a provider. But if you are to look, and again, yeah, looking at the type of providers, as I did already show you, you have community providers, you have verified providers, you have official providers. The one good thing about providers under Terraform is that they let you sign, they let you use GPG keys to sign your provider code. So this is good. On the providers end, we are well and good. There are good security practices in place. But when we were to talk about Terraform modules, we'll understand that these modules can have varying sources from which they can be loaded on. So it's not just a Terraform registry. You can share specific module. A developer can share their Terraform module that's hosted on their machine with another developer machine, and they can load it from GitHub repositories, Git repos. But the statement that is worrisome is that there's no concept of verified or unverified modules. So there's no good security framework around Terraform modules. There's no concept of actually enforcing signatures on these modules. There's no concept of actually verifying if there are any signatures. There's no concept of verifying such signatures. So this is worrisome, and this is pretty much how a threat actor would look at Terraform modules. They would look at Terraform modules as an entry point for their attack. So moving on, we can jump onto our lab, which is malicious Terraform modules. So let me quickly spin that up. Yeah, so we have our lab here at learning.appsecEngineer.com. So the lab is going to look like this. So let us just quickly click Start Lab. You'll also see that you have a comprehensive documentation right down here if you scroll down. So this kind of helps one run this set of commands and pretty much simulate the attack part of this lab and also the defense or detect part of this lab. So these are helper commands that let you quickly get onto the lab and pretty much start with your attacker story.
Yeah, so this is pretty much the interface that you will be experiencing when you are attending the boot camp, because we'll have so many hands-on labs. So I'm guessing this is one of the labs that will be in the boot camp as well, right, Abhishek?
Yep. This is gonna make it up there. It's pretty much a flagship lab, if you were to ask me. So yeah, this is just one of those labs, and yeah, we'll have a lot more.
That's great, because we try to keep it as hands-on as possible with AppSecEngineer. And if you've actually seen our platform, this is pretty much how we, how we do these things. So it's like we try to make sure it's as real world as possible. So yeah, that's how we.
Yeah. So as you can see, we have a lab provisioned. We just click Access Lab and taken right into the terminal. You'll be seeing pretty soon. So yep, we do have our VS Code ID up and running, and let's quickly get our terminal started. So the first thing first is we are going to provision a sandbox AWS account. So again, just as a side note, you need not have an actual AWS account in place because we're going to do that for you. We're going to provision a throwaway sandbox AWS account by running this command right here. So ACCTL init AWS will pretty much go forth and give you temporary throwaway access key, secret access key, basically your own cloud environment for you to experiment on. So moving forward, we'll also be launching a shell. And let me explain what this does. So I will pretty much rather rename the terminal so that it's easier to understand. In this lab, the first thing you need to understand is we're going to simulate both an attacker as well as a victim. So this is the attacker's terminal. So I assume this is an attacker system. So an attacker has the listener running. This listener at the end of the day is going to pretty much fetch credentials, right? So moving forward, we pretty much have a Terraform module which is vulnerable, which is malicious in nature. So Terraform module, as you can see, looks like this. They're pretty much basically a bunch of TF files. TF again stands for Terraform. This is one of those modules. So let me give you a quick walkthrough of this module. This is a malicious module, and I'll explain the malicious nature of it. But to begin with, this module is going to make use of the AWS cloud provider, as you can see right here. So this specific code block is responsible for that. And under AWS, we want the module pretty much wants to spawn an AWS as some parameter. And the name of the parameter is going to be a secret parameter, and we're going to feed it with a random password hash. So that's what this module does. It's going to talk to the AWS provider, and within AWS, it's going to spin up or pretty much deploy an AWS as some parameter resource with a random hash password. So again, this is going to take place within a sandbox AWS account, so which is again a throwaway account. So we are good to go there. And the malicious aspect of it starts right from here. We are going to make use of a data block that is pretty much going to share this password to the attacker's listener. So let us actually run this attack and see how it looks like. And prior to running any Terraform script, we run Terraform init or initialize. So Terraform here is going to fetch whatever is required. Let me go to the right directory. Yeah. So again, we run Terraform init, and you'll see that it's going to fetch all the required providers or everything basically that is in use. See, again, data uses HTTP. So it's also going to fetch hashing of HTTP model from the registry, and all sorts of plugins that are required for this module to function. So once this is done, let us just quickly run this module. We do so by running this command called Terraform apply auto approve. So if you were to run it with the auto approve flag, the user would not be prompted. Right? They will not be prompted with the yes or no question. They'll just be, everything is just yes by default. So on hitting auto apply approve, this is going to take some time, but an attacker an attacker who's written this malicious module and has his module shared with the victim, and the victim then later running it would pretty much look like this. So on the attacker's end, you're going to see that the SSM parameter, the secret password, that the module was responsible to just create, the module was responsible for creating within the AWS cloud provider is already shared with the attacker. So this is pretty much unintended. For added impact, we can also make use of the file function that Terraform inherently supports. So that is going to look like this. So let me just quickly show that where show a vector or show added impact wherein etc password pretty much leaks out. So in order to do the same, we'll again be hitting Terraform init. So this just goes to say how extensible Terraform is. It supports a lot of inherent functions. This specific function right here lets us read the local file system. So let me just again quickly go and apply this Terraform module. So we are going to read etc password, and then we are going to base64 encode it and send it to the attacker. So as you can see on the attacker side of things, they have the contents of etc password. Let us quickly decode this as well. And as you can see, yeah, it's pretty straightforward. Now, talking with regards to detecting such attacks. Okay, as a victim of such an attack, your next step would be to somehow, try to detect it prior to the attack taking place. So prior to applying such modules, or prior to using such modules, your first intention would be to review this module, right? So there's a tool called checkout that kind of helps you do it. So this lab already has it installed. Let's just run and look at the version that we're using. We need to use the latest version of checkout. So yeah, 3.2.461 is the latest version as of today. And in order to use checkout, again, checkout is a static analysis tool that lets you review or audit your Terraform code. So we have this model. So again, now as a victim of such an attack, I'm going to make use of checkout to kind of help me flag a malicious model. So in order to do so, I'm going to run checkout against with the flag D on the model that I've just thought of using. So again, as you see, once checkout does run, we see that a lot of checks fail, and the attack and the major attack point is easily flagged by checkout, and it says that you're pretty much sending SSM secrets or to an untrusted domain over HTTP. So it's pretty much flagged. So prior to hitting, so as a developer who has just learned about checkout, I'm not gonna apply that module anymore because I've just flagged an issue with it. But I'll also show you how easy it is to circumvent such checks, from static analysis tools. So in order to do so, an attacker could rather pretty much make use of, you can just uncomment this, an attacker could pretty much make use of the base64 function that was not in use here. So again, this pretty much exploits Chekhov's parser depth because Chekhov pretty much, when Chekhov does go through your Terraform module or your Terraform file, it starts creating a dependency graph of sorts. So it's going to first look at this resource, and it's going to then chain it or connect it with the usage of this resource. So in this specific case, it would look at this resource, keep it in its dependency graph, and then look at the URL parameter, and then quickly realize that, okay, you know what, this specific resource is referenced here. So there's a direct connection between the same. So if you have to look at a Chekhov rule, it's going to look like this. This is the Chekhov rule, and GitHub. So this is pretty much the exact rule. This is where Chekhov. Let me just quickly thank you. This, yeah. So we have the Chekhov ID here, and this is how the rule looks like. This is what Chekhov follows. The rules are written in YAML, and as you can see, it looks for a connection. It looks for a connection and looks for an SSM parameter if connected within a data HTTP block. So in our case, it was. But in order to circumvent such a check, we just change this specific usage of SSM parameter. We'll pretty much embed this variable or this parameter within a function. Let's just do that right now. Let's see how that works. So let's quickly. Yep. So I'll uncomment the first data block because it was caught by Chekhov, but let's try to circumvent and let's try to bypass Chekhov. So in order to do so, again, I'll just be wrapping this within base64 encode function. And now, attempt running checkout. So as you can see, you do remember this check basically failed. We will pretty much see this check passing. Yeah. So as you can see, sure, Terraform, this specific check again is a pass now. Checkout says that there's nothing wrong with this specific module and it's all good to go. But as we know it, the attacker is just pretty much circumventing this sort of a check by encompassing this parameter within this function. So this pretty much beats checkout and the attack would still be viable. So again, this kind of also speaks aloud a lot of issues with static source code analysis in general. So again, it's not up to the mark, and there are a lot of hopefully there are a lot of upcoming ways in order to detect such attacks, especially with the rise of AI and LLMs. So yeah, I think this pretty much concludes my demo of this lab.
Great. Thanks so much, Abhishek. That was really illuminating. And I'm sure our audience has learned a lot about
Yeah.
they've learned a lot about supply chain security through this, and they have the opportunity to learn a lot more when we get into our actual boot camp. So let me just tell you a little bit about what we're going to be doing. And Abhishek will be your instructor for the supply chain security class as well. So when you sign up for a boot camp, you can attend the live class, access the recorded content for 1 year after purchase, along with getting 1 full year of access to the AppSecEngineer Pro Plus subscription, which means all the courses, labs, and challenges on our platform. So it's the complete package. But there's not only that, you will also be able to take our certification exam in the relevant AppSec engineer certificate. So in this case, it would be supply chain security, but we also have the 5 others which I mentioned earlier. So you will need to take that within 1 year of attending the boot camp. And with that, you'll officially be a certified application security professional with hands-on skills in real world problem solving and security knowledge. So, by the way, we are giving away a 10% off code for a discount code for all these webinars. So, if you want to get a limited time offer for the supply chain security class, just use the code Abhishek10 and you'll get 10% off your purchase of the certified supply chain security bootcamp hosted by Abhishek Dharani. So we'll include the links down below where you can hear all the details. But let me just say that this is one of the most incredible learning opportunities available anywhere in the industry. And I really can't wait for all of you to experience it. Thank you so much for joining us, Abhishek. And thank you so much for being here with us to our audience. And we'll see you in the bootcamp very soon. Thank you. See ya.
Thank you. Thank you. See you. Bye bye.